Okay, so here's our third video on graphing quadratic functions or relations using x-intercepts. In this video, I'm going to show you a few examples that won't work. You can't always use the x-intercepts. So in this case, we'll try finding our x-intercepts. Find the x-intercepts, which we do by letting y equal to 0. So 0 equals x squared plus 2x plus 1. So then we'll factor. And notice here that we want the numbers that multiply to 1 and sum to 2. You might recognize that's actually, that's actually a perfect square. It's actually 1 and 1. So we have x plus 1 squared. Which means that x plus 1 is equal to 0, which means x, just by subtracting 1 from both sides, x is equal to negative 1. So we only have one x-intercept. So what we've got is one x-intercept at negative 1. So there's our x-intercept. So how come there's only one x-intercept? Well, this must mean that this is the vertex. The vertex happens right on the x-axis. So we can't go through the procedure of now finding the axis of symmetry, because actually this is the axis of symmetry. The vertex happens right there. And we can't then find the vertex because we've already found the vertex. The vertex is minus 1, 0. It's right on the x-axis. And actually you might be able to see that when you factor this, right? Let's do it up here. When we factor this, x plus 1 equals 0, this is vertex form. When you factor this one, because it's a perfect square, you kind of complete the square. You've got the vertex form. So you maybe could just graph it like this. So in a sense it does work, because we're still able to graph it because we found the vertex, and then we can just use kind of our transformation of just shifting this over 1 to the left, of just shifting y equals x squared over 1 to the left. So all the points go 1 to the left, and I'd be more accurate about actually, having a scale and things. But the procedure from the other cases won't work in the same way, because you only have the one x-intercept. So just be aware of that. If you do get the one x-intercept, you can't use, you won't follow the same procedure. You just, use vertex form in that case, because it's vertex form shows up very easily. Okay, so here's another example that I'm warning you about, so I'm telling you. Okay, so you try doing the same thing. So you try find the x-intercepts, and then you'd let y equal 0. So 0 equals x squared plus 8x plus 3. So here's the issue. Try factoring that. You need a product of 3, should be a colon, and a sum of 8. Well, you're not going to find two numbers that do that. So the issue in this case is you can't factor in order to find the x-intercepts. So we know that not every quadratic is factorable. So if you can't factor it, you can't use this method of finding the x-intercepts. Let's just to sort of see what's happening. Why did this happen in this case? What does the graph look like? We could still use that method of changing to vertex form. The good thing about changing to vertex form, or completing the square, is that method always works. So just to see what the graph actually does look like and why maybe we couldn't factor. So we'll add half this term squared, 16 minus 16. So x, and we'll group the first three terms. x plus 4 squared, negative 16 plus 3, negative 13. So y equals x plus 4 all squared, subtract 13. So if you wanted to sketch that, the vertex would be negative 4, negative 13. And I'm not going to sketch this totally using transformations. I'm going to just plot the x-intercept roughly. So negative 4, we'll maybe we'll say negative 13 is down here. And it's facing up, so we've got a parabola like this. So it does have x-intercepts, right? The x-intercepts are somewhere here, but why couldn't we find them using this method? Well, the reason is they're really bad numbers. We could substitute 0 into y here, and then try solving. So add 13 to both sides, get 13 equals x plus 4 squared, take the square root of both sides, plus or minus, and then subtract 4 from both sides. Just going to flip things around here. So the x-intercepts would be root 13 minus 4 and negative root 13 minus 4. Well, that's a really ugly number. That's a decimal that there's no way, it's a non-repeating decimal. There's no way you were going to be able to figure out those factors. So there are numbers that do what you want it to do up here. They're just irrational numbers. They're not repeating decimals. Or they're not even, they're definitely not integers. They're not even fractions. So there's no way you were going to be able to guess those. So that's one case when you couldn't graph using the method of finding x-intercepts. When the x-intercepts are so kind of wacky that there's just no way you're ever going to figure it out. Let's make this 2x plus 10. So here's another one that you would try. First let y equals 0, and then we'll try factoring. So again, you can't factor. You can't. So product of 10, sum of 2. Good luck finding those two numbers, right? So is it the same situation as before, where the x-intercepts are just so kind of ugly that there's no way we could ever figure them out? They're not whole numbers that we could ever guess. Well, let's try doing the same thing. We'll write it in vertex form. So we'll complete the square plus 2x. So half of 2 squared is 1, subtract 1, and then leave the 10. So just right there, just kind of inserting that. Group the first 3 terms. So we get x squared. Oh, maybe I'll group the first 3 terms, and we'll factor that trinomial. X plus 1 squared minus 1 plus 10 is plus 9. So in this situation, here the vertex is negative 1, always the opposite of that, 9. So again, very roughly sketching. Let's put our x-axis down here. So this would be negative 1. We'll say 9's up here. So there's our vertex. But notice, which way does the parabola open? It's opening up because the coefficient, oh, it's an ugly parabola, but whatever, you get the idea. The a value, the number in front of x squared, is positive, meaning it opens up. Well, this has no x-intercepts, right? The x-axis is down here. It's never going to cross. No x-intercepts. No x-intercepts. So the reason that we couldn't factor up here isn't because the x-intercepts were so ugly that the numbers are just too difficult to guess or figure out. There's no numbers that would work. It's impossible. So this one's what we call, it's unfactorable even like with decimals. You couldn't factor it at all. So that's the reason that this one won't work. So if your vertex is above the x-axis and you're opening up, you're never going to have a x-intercept. Similarly, if the vertex was below the x-axis and opening down, again, there would be no x-intercepts. So you do get those two cases where you don't have x-intercepts. So in that case, if you're asked to graph it, the only way to do it would be this way. And you'd, of course, do it a little bit better than this. You'd actually figure out the vertex and then use transformations of x squared to be more accurate than I was. I was just sketching it so you get just for a rough idea.